Hello, Ma'am Aubrey here, and welcome to Module 6. In the past modules, we have been discussing what are the resources on Earth that are as important for human development. So we have already discussed rocks, minerals, we have also discussed energy resources, and now we are moving to another underrated Earth resource, and that is water. So for our learning objectives, by the end of this module, you should be able to identify the various water resources on Earth and explain how different activities affect the quality and availability of water for human use. So, why should you care about water? Well, we already know that water is very important for our own health and well-being, to keep hydrated, but water also plays a very important role in our human modernization. So without it, we wouldn't have these large cities and inventions that we see today. So just to further my point, the major cities of the world are always near water. So if you have been around the world and visited the different megacities, they will always be coastal in nature. So some examples are Tokyo, Japan, New York City, Shanghai, China, and Manila, Philippines. So including us. The cities are always situated near water because it is a very important resource. So it can be used as a means of transport, so either by boats or submarines if you want to be fancy. Source of food, so either aquatic products like fishes, algae, and other seafood necessary for economic production. So we use a lot of water in order to produce our everyday products. Even if you don't think that we use water in those production like plastic, coke, snacks, and pretty much all the products that we produce would require water. And of course, it also supports other ecological benefits. So aside from supporting the modern human society, it also supports the other forms of ecosystems here on Earth. Okay, so the amount of water in our planet is fairly constant. For millions of years, the total amount of water on Earth has remained fairly constant. Rates of evaporation and precipitation are balanced. So, what does that all mean? It means that the amount of water that has been present even before the dinosaurs is fairly the same amount as what we have today. So meaning what we have right now on our planet is gonna be the amount of water that we will have for the next million of years. There are some small additions and some subtractions in that amount, but if you have an average, it would remain fairly constant. It means even if we have a large amount of evaporation and precipitation in our Earth, of water on Earth, it still remains constant. Then that's because of the hydrologic cycle. So you may be familiar with the hydrologic cycle and call it the water cycle, but if we want to be like very scientific, we could use the term hydrologic cycle instead. Okay, so the hydrologic cycle has its own components, natural components. So first, you have your precipitation. This is the collective term for the water which goes down from the clouds towards the earth, and it could be present through snow or rain. So both of those are types of precipitation. Then after the rain, of course, it will now infiltrate to the soil. So that means it will be absorbed by the soil as moisture. So soil and rocks is infiltrated by what? Precipitated water. Next, you have your surface runoff, meaning the excess water that the soil or the land cannot absorb. Then it will create a surface runoff wherein it will start flowing wherever gravity takes them pretty much. So excess surface runoff, of course, will lead to flooding. Now, it may also result to groundwater. So what does that mean is the water infiltrates to the soil. So instead of be flowing on the surface, it might go deeper into the soil and near the bedrock where it will accumulate. So more of surface water and groundwater later on. Then there is also a component of our hydrologic cycle which is stuck or found in living things. So that's called evapotranspiration. So evaporation and transpiration. So evapotranspiration is the movement from water, bodies, soil, and living things. So that's also us. We are part of the evapotranspiration. So here, this picture right here gives you an overview of how much water is evaporated and precipitated per day by cubic kilometer. Okay, so just a review of our current water resource. So water makes up 70% of the Earth's surface. And if this picture is familiar to you, because I already used this in the hydrosphere discussion. So just reviewing this, again, 70% of the Earth is covered by water, but not all of that is accessible for human use. So 97% of the world water is salt water, so we can't use that. So instead, we use that small 3% as fresh water. The 3% is distributed in different parts of the world. 69% of that is stuck in the form of ice or glaciers. 30% is underneath the earth in the form of groundwater. And then 1% is present as surface water. Now, we'll go deeper into the definitions of surface water and groundwater. So surface water, again, is 1% of the Earth's fresh water, and that's not always present as accessible water for us. So 20% of that will be present as lakes, soil moisture, so 3.9%. It could be in the atmosphere in the form of clouds, and that's 3%. There are also swamps and rivers that hold our fresh water, and a very small percentage is within our living things. So surface water could be present naturally or artificially in the formations where water can accumulate. So the surface water the locations where water can accumulate is called reservoirs. So 68%, of course, ground ice or permafrost. So permafrost is actually a form of ground ice. So reservoirs, if we say formations where water can accumulate, so that should include lakes, swamps, marshes, rivers are all reservoirs. So either natural or man-made. So the dams and man-made lakes will also be classified as reservoirs. So ponds, rivers, streams, all of those are reservoirs. Okay, now this is different to groundwater. So surface water is everything that is accessible without digging up the earth. But we also have groundwater, and it's much larger than what we have in the surface. So groundwater refers to the subsurface water contained in pore spaces in regolith and bedrock. So when we say regolith, this is the product of weathering of parent rocks. Okay, so groundwater could either be present within the soil or just before the bedrock. So the volume of groundwater is 40 times larger than surface water. That's why in cases of water shortage, groundwater is always considered as a viable solution. Accessible groundwater is no more than 750 meters below the ground. So that means that we will just dig a fairly short distance in order to access it. Natural formations where water accumulates underground is called aquifers. So again, the accumulations on the surface is called reservoirs, while those that are underground is called aquifers. Okay, so this picture right here that you can see on the screen is called an aquifer. Okay, so just to give more example of how groundwaters work. So for example, you have rain that will precipitate from the clouds, and of course it will hit the earth's surface. And some of that will accumulate here as a layer of soil moisture in order to support the growth of plants. However, there will be a limit wherein the water from the surface, let's get a marker. The water from the surface here, okay, so let's say it's raining, and then some of the water will accumulate here on the surface, but not all the water will stay. There will be an area here where it is made of a porous rock or soil, and what will happen is the water will flow through and deposit into something called the water table. So the water table is where the non-saturated soil meets the saturated. So here, not saturated, this layer, zone of aeration, and then you have saturated layer. So this layer right here has also some soil and porous rock, but it is saturated with groundwater. Then here at the bottom is impermeable rock, so it's not porous, water can't go in, and it's sometimes referred to as the bedrock. So since you have an impermeable layer here at the bottom, you will have here the aquifer where water will accumulate. So this is something that we tap whenever we're digging wells. So let's just erase everything. So whenever, erase all. Okay, whenever we are digging up water, so for example, there is a location where they need an accessible amount of water, we could dig up wells. So you have to pass through a layer of soil moisture and a layer of zone of aeration, and then dig into the water table and the porous rock with the aquifer. Okay, so that's how our wells are made. Okay, so you could, instead of building a mine, you could do this in a large scale. So you could like dig and put a tube downwards where the water from the ground will be vacuumed out into the surface for easier access. And that's called groundwater mining. However, this also poses some environmental risks because the water underneath also is important for structural support. So if the rate of withdrawal, discharge, so the amount of water that we are getting from the environment is exceeding the natural recharge or the precipitation or the amount of rain basically that it gets from the surface, then the volume of groundwater will steadily decrease. So since we have an area here where water is being vacuumed upwards, it creates a cone of depression where there will be some space here within the rock itself, and then water will start flowing downwards in order to go up into the surface. Okay, so this will result to the lowering of the water table, and it may cause droughts in other locations where it is dependent on the water table. So springs and streams on other locations may dry up, and the compaction of the aquifer might occur. So meaning the aquifer itself will start to shrink because water is no longer present. Then because the aquifer is shrinking, the land will sink. So that land sinking is called subsidence. So the surface itself may sink lower because there is no water anymore to structurally support it underneath. This is very difficult to survey. So water is important. That's why we need to get water from underneath the ground. I mean, in comparison to surface water, there is more groundwater. But since we're getting water from underneath the earth, it's actually hard to monitor if we are already discharging way too much than the surroundings can support. So this is one of the challenges when it comes to proper water management. Okay, so speaking of water management, there are, of course, human activities that causes contamination of accessible water. So, for example, untreated sewage, and this reminds me of the issue back in Boracay before they started rehabilitate the location. So, the sewage that we use for the dirty water that we throw away could be directly discharged into the water, but that's dangerous because it's toxic water. So it could pollute the plants and animals, the fishes that are living in the water, so making the water itself uninhabitable and unusable for normal human use. Okay, so excessive use of agricultural pesticides and fertilizers. So if you keep putting nitrogen and phosphorus into the soil, that will create a surface runoff. So the water will absorb the excess fertilizer and then it will start mixing into the water table. So aside from the agricultural pesticides and fertilizers, it could also be contaminated with harmful chemicals, heavy metals. So it could be contaminated by gas stations, refineries, and other industries. And that's aside from the human pollution that we cause. So the amount of trash that we throw into the ocean, creating like a plastic ocean in a supposedly clear water. So we will be discussing more of pollution in a separate module. Okay, so fresh water is not distributed equally across the globe. So even if we have a lot of fresh water that we can work with, either in surface or groundwater, not all countries have that access. So for example, Canada only has 0.5% of the world's population, but they have 20% of the liquid fresh water because they are a cold country, they have ice over there. So even if they have the fresh water, aside from the solid fresh water they also have the liquid fresh water. China, 19% of the world's population, has 7% of the liquid fresh water. In Asia, which has 60% of the world's population, has 30% of the liquid fresh water. Then the rest are distributed in the other continents. Okay, so when we're talking about freshwater withdrawals, these are the amount of water that we take from the natural environment for human use. So the amount of water taken from the natural environment to be used for human activity. So it can be classified, those freshwater withdrawals can be classified into 3 activities. So agriculture, so we need that in order to grow our crops, maintaining livestock in order to provide food for the rest of humanity. We also use it in industry in order to create manufactured goods, and then domestic, so the normal everyday use of water. So when you shower, you do your laundry, clean the dishes, drinking. So those are our freshwater withdrawals. And the use of water, of course, is not equal. So whenever we say conserve or protect water resources, one of the movements is always like in the human small scale. Like when you brush your teeth, you have to close the tap, or when you flush, you should use non-potable water, so like recycled water. But in actuality, in South Asia, we only use a very small amount of fresh water for our domestic use. It's just about 8%. The majority of our use is actually in agriculture. So over here, you will see that this dark blue is the use of agriculture. So South Asia being mostly agricultural countries, we use like more than 70% of our fresh water just for agriculture. Then a small amount for industry and an even small amount for domestic. So if we actually want to save water in South Asia, we should focus on our agricultural use. So we see similar trends in Middle East, Sub-Saharan Africa. Then here in Europe and Central Asia, I think industry is also a main player now, because instead of being agricultural countries, they prefer to focus their economy into producing goods or manufacturing goods. So industry would consume a lot of fresh water, agriculture, and then domestic also for them. Yeah. So that's an overview of how the world uses our fresh water. Okay, so this image gives you the scale of global scarcity of the world. This is taken from a National Geographic article, which I also linked in our BBL. So if you're curious about the water scarcity, there is an article in 2018 that gives an overview of its situation. So this picture gives you a estimate of how many countries, or what are the countries in the world which are experiencing droughts. So naturally, you would see that it's very red here near the equator. Now, the dark red are those that experience 12 months of droughts. Can you imagine, like 12 months of droughts? Philippines here barely feels droughts. Like we complain of El Nino like in the summer, but it's not even close to what the other countries are experiencing. So for example, Australia, some parts of Africa, California, in the United States, they're experiencing long periods of droughts where there is no rain and they don't have any fresh water to draw water, like just to use for industry, agriculture, and everyday use. Okay, so there, Philippines is quite lucky in terms of water resources. Now, because there are countries that are struggling with water resources, of course, they turn to technology in order to better themselves. So one of these technologies is thermal desalination. It's quite like an old technology, thermal desalination. So the process of thermal desalination involved extracting fresh water from salt water. So you take water from the ocean, and then due to the energy of the sun, you will separate the salt components from the water. So the result is salt will be isolated, and what you will have is fresh, clean water that we could use for our own purposes. Okay, so due to it's now expanding, like there are several countries that are adapting this type of technology. Thermal desalination is, of course, like an old technology. There are now more emerging and more efficient ways in order to desalinate ocean water. It's popular. It's a popular solution to droughts. It used to be quite expensive, but because there are more countries adapting its use, it's becoming cheaper. On the other hand, we must consider as well that desalination will also have its environmental impacts. So, for example, the oceans themselves will be affected, and also what will you do with the excess salt that you have taken from the ocean? Will it mix with the soil and that will damage the soil, or will you dump it into fresh water? So we could only consume so much salt in one day. So if you dump it back into the ocean, it will increase the salt content of the ocean, and that might be deadly to some of our marine life. Okay, so we should also be careful if we're going to adapt desalination in a large scale. Okay, so those are everything about water resources. We have identified where we get the water resources on Earth, and we also identified some of the activities that affect the availability of water. Okay, so if you have any more questions, you know how to reach me. Microsoft Teams and Messenger are well recommended, so I could reply to you easily. That's all. Stay safe. Bye.